Hey everybody. Today we're going to be talking about parallel lines and angle pairs. So we are going to prove and use properties of parallel lines cut by a transversal. So kind of like what we did yesterday, only our lines are parallel now, the ones that are being cut by the transversal, and we're going to be able to prove that lines are parallel. Okay, so the first thing I want to talk about with you guys, and we're not going to use it a whole lot today, if at all, but we're going to need them for tomorrow. And I don't want the first time that you see them to be tomorrow. So these are some kind of like, well, duh properties. Okay, you're going to like these. The first one is called the reflexive property of congruence. That just means that any figure is congruent to itself. Like I would be congruent to myself. So angle 1 is congruent to, angle 1. No surprise there. Okay, if I say segment AB and I want to use the reflexive property of congruence, I can say segment AB is congruent to itself, segment AB. Okay. All right, the next thing is the symmetric property of congruence. This just means that I can flip congruent statements around and they still mean the same thing. So if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. Easy. All right, if I say that segment AB is congruent to segment CD, then segment CD has to be congruent to AB. Well, duh. These are kind of like, well, of course they have to be, but they actually have names, and I want you to know the names. All right, next is, this one's my favorite. This is the cool one. This is the transitive property of congruence. Okay, so if angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, then angle 1 has to be congruent to angle 3. Right? Because they're all congruent. Well, duh. All right, last one. So if if segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then segment AB is congruent to EF. So AB and CD are congruent, and then CD and EF are congruent. So these two also have to be congruent. That's all we're saying. I gave you examples with angles and segments because that's what we're going to be using the most on, but it can work on triangles and stuff too. So any figure you can use these on if you have congruent figures. Okay. Well, duh. All right, now we're going to get into the meat of it. Okay, remember that a postulate or axiom is a statement that is accepted as true without proof. Okay, so we're never going to prove the corresponding angles postulate because we can't. We just accept it. Okay, but we're going to use it. So it says this: if two parallel lines, this is the different part from yesterday. Our lines were not parallel yesterday. Are cut by a transversal. You know what? I had kind of a good thing going with my hot pink transversal, so I'm going to make my parallel lines blue so I don't confuse myself. Parallel lines are cut by a transversal. So here's my transversal. Okay. Then the pairs of corresponding angles are congruent. Now this is super important because yesterday we learned how to identify corresponding angles. So now we're saying that if those lines cut by a transversal are parallel, our corresponding angles get to be congruent. That means angle 1 is congruent to angle 3. Okay. Angle 2 is congruent to angle 4. Those are corresponding. Angle 5 is congruent to angle 7. And the last one, angle 6, is congruent to angle 8. Okay, so each of the corresponding pairs are congruent. So for this bottom one, we have to find each angle measure, and then we're going to tell which postulates, theorems, and properties we used. Okay, so they're telling us that this guy over here is 118 degrees. And they want us to find the measure of angle 3. Well, the 118 degree angle and angle 3 are vertical angles. And we know that by the vertical angles theorem, they are congruent. So angle 3 is also 118 by the vertical angles theorem. Okay, now we want angle 1, measure of angle 1. Look at this. Okay, there's my hot pink transversal. Here's my interior of my parallel lines. Notice that angle 1 and the 118 degree angle are on alternate sides of my transversal, but they are both in the interior. So they are alternate interior angles, and they are congruent. Oh, you don't know that yet. Okay, you don't know that yet. Back it up. Forget I said that. You're going to find that out in a minute. Okay, so we used 118 to get angle 3. Okay, now we know that angle 3 is also 118. Okay, so look at angle 1 and look at angle 118. Okay, those are corresponding angles. So in order to get that, we had to use the vertical angles theorem from getting angle 3. Okay, and then we also had to use the corresponding angles postulate. Sorry about that, guys. Okay, that's how we can tell that the measure of angle 1 is also 118 degrees. Sorry, I just went into your future. Okay, next. The measure of angle 2. Well, look at this. The 118 degree one and angle 2 have a common endpoint. They share a common ray. And then their non-common sides form a line in opposite rays. So those two are a linear pair by the definition of a linear pair. Okay, we now know that linear pairs are supplementary. Oh, not spell. Okay, we also know the definition of supplementary. Says that the measure of angle 2 plus 118 degrees has to equal 180. That comes from the definition of supplementary. So if we subtract 118 from 180, we get 62 degrees. Okay, this is what I was talking about before when I jumped the gun. So here are some new theorems for you on parallel lines and angle pairs. Remember that a theorem is a statement that can be proven true. So the first thing we're going to do on this first little picture is shade our interior, because you can see that both of these are talking about interior. So we're going to shade the interior. Okay. I'm going to make my transversal hot pink. An eye-catching color. So the alternate interior angles theorem says that if two parallel lines are cut by a transversal, then each pair of alternate interior angles is congruent. So we're in the interior and we want alternate sides of the transversal. So that would be 1 and 3. Angle 1 and 3 are congruent. Angle 1 is congruent to angle 3. Okay, also, angle 2 and angle 4 are congruent. Okay, now we're going to look at same side interior angles. Okay, same side interior angles would be like 1 and 4 are same sides, and 2 and 3 are same sides. No, I got that backwards. Sorry. I skipped that day at school. Okay, so same sides would be 1 and 2. And 3 and 4. Those are same sides. Sorry about that, guys. Hopefully you didn't do that in pen. Okay, so what we know about same side interior angles is that each pair of same side interior angles is supplementary. And we know from the definition of supplementary that the measure of angle 1 plus the measure of angle 2 has to be 180 degrees. Also, the measure of angle 3 plus the measure of angle 4 has to be 180 degrees. Supplementary means we add up to 180. Complementary means we add up to 90. Sorry that I boxed the wrong ones. I feel really bad. Okay, we're going to switch to a new picture because that one got gross. Now we're going to talk about exterior angles. So we're going to shade the exterior. All right, now we want alternate exteriors. So alternate sides, opposite sides of my transversal. Go ahead and label your transversal. Okay, so 5 and 7 are, I didn't tell you what the theorem was yet. Okay, it says if two parallel lines are cut by a transversal, then each pair of alternate exterior angles is congruent. Okay, so 5 and 7 are congruent. Angle 5 is congruent to angle 7. Okay, that also means that angle 8 is congruent to angle 6. Okay, for same side exterior angles, if two parallel lines are cut by a transversal, then each pair of same side exterior angles is supplementary. The definition of supplementary is that we have to add up to 180 degrees. So, if I look at angle 5 and angle 6, those are on the same side of my transversal, and their exterior, they have to add up to, their measures have to add up to 180. So the measure of angle 5 plus the measure of angle 6 is 180 degrees. And then also the measure of angle 7 and the measure of angle 8 have to add up to 180 degrees. Measure of angle 7 plus the measure of angle 8 is 180 degrees. Whew, we're on a roll now. Okay, so hopefully you wrote all that down. We're going to refer back to it. So we have this cute little figure, and in the figure, the measure of angle 1 is 104 degrees. We have to find the measure of each angle, and we have to tell which postulates, theorems, and properties we use. So if I look at the measure of angle 1 and like angle 3, okay, they are on the same side of my transversal, and they're also on the same side of the parallel lines that I left blue. They're both on the left. So they are corresponding angles, and corresponding angles are congruent. So 3 has to be 104 also by the corresponding angles postulate. Okay, for angle 5, compare that to angle 1. They're on alternate sides of the hot pink transversal, and they're both in the exterior. See? Exterior, exterior. So they are alternate exterior angles, so they are congruent. So angle 5 is also 104 degrees by alternate exterior angles theorem. Okay, angle 4. Angles 1 and 4 are still in the exterior, but they are on the same side of the transversal. So they are same side exteriors. Same side exterior angles theorem, which says that they have to be supplementary. So we know that the measure of angle 4 plus 104 degrees equals 180 degrees. So we have to subtract 104 from 180. And when I did it, I got 76 degrees. Okay, that one was kind of a lot. This one's better. Angle 7. Look at that. It's right opposite. Okay, those are vertical angles. And we know, thanks to the vertical angles theorem, that vertical angles are congruent. So their measures are the same. 104. Bam. Okay, look at the measures of angles. Okay, look at angles 1 and 2. They have a common vertex and a common ray as a side. Their non-common sides make opposite rays. They are a linear pair. Okay, we know linear pairs are supplementary. We also know the definition of supplementary. Okay, so by the definition of supplementary, the measure of angle 2 plus 104 degrees has to be 180 degrees. Okay, so just like angle 4, the measure of angle 2 is 76 degrees. Whew. All right. We're only going to do one on example 3 because some of them are a little redundant. All right, so we're going to find the measure of, okay, we have a new picture. It says the measure of angle 4 is 101 degrees. So if we're trying to find the measure of angle 6, well, I see that they are on alternate sides of the transversal, and they are in the interior of my parallel lines, so they are alternate interiors. Oh, that's a highlighter. Alternate interior angles theorem, which says alternate interior angles are congruent. So this one would also be 101 degrees. Okay, this 7 is a typo. It should be 8. So if you want to go in and see if you can find them, change that to an 8, please and thank you. Okay, we're going to move on. Okay, so for each of these, you guys are going to love this because we can just math it out. We don't have to like justify our steps or nothing. We just have to find the variables. Algebra! Back when the world was simple. Okay, so if I'm looking at these angles here, I see here's the interior, here's my transversal. I see that the X, oops, I see that X degrees and the 55-degree angle are a linear pair, so there have to be supplementary. So those two have to add up to 180. So X plus 55 has to equal 180. If I subtract 55 from both sides, I get that X is 125. Okay, now X and Y, those angles, those are alternate sides of the transversal on the interior. They're alternate interior angles and they are congruent. So if X is 125, so must Y be. Okay, we didn't have to write anything down. I'm just so I can abbreviate because it's just for me. It's not an answer because I don't have to write anything down on this one. So I'm allowed to abbreviate. It's the one time. All right, look at the next set. Here's my hot pink transversal. Okay. My angles are in the exterior of the parallel lines. They are alternate exteriors. And if they're alternate exteriors, they have to be congruent. So their angles have to be equal. Their angle measures have to be equal. So X minus 10 has to equal 104 degrees. So just add 10 to both sides and you get that X is 114. Okay. And back to interiors. Interiors, and they are on alternate sides of my pink transversal. So they have to be congruent. So I can say 2x. If they're congruent, their measures are equal, right? So 2x minus 15 has to equal x plus 55. Okay, subtract x from both sides and I get x minus 15 equals 55. Add 15 to both sides and I get x is, is it 70? Yeah. Don't tell anybody I checked my paper. All right, next. Okay, that was the warm-up round. These are the beastie ones. All right. Now, if you have been refusing to use your colored pencils or like erasable colored pens, like today is the day to not die on that mountain. Okay? Just embrace the colors because it will help you a lot. Because look, I have two parallel lines. Okay? And I also have two different hot pink transversals. Okay? So we're only going to look at one at a time, but like you really are going to need the colors. It's going to help your brain. So we're going to ignore the bottom part of the problem for right now and just concentrate up on the top part. Okay? You can even like stretch this out for right now. Do it lightly because we're going to need it. So these are my parallels. Oops. Okay, and then my transversal is the pink. So the interiors, this is the interior. So you can see that the 96 degrees and the 2x degrees are on the same side of the transversal in the interior. So they are same side interior, same side interior angles, which are supplementary. Okay, so the first part is that we say that 96 degrees plus 2x equals 180 degrees. Actually, let's just divide out the degrees so we don't have to mess with them. That's what we have been doing, but I kind of forgot to do it. Sorry. Okay, subtract 96 from both sides, and I get 2x equals 84. Divide both sides by 2, and I find that x is 42. 42. Okay. That was one part. Now, we're going to use the other part. So we still have our two parallel lines. Okay, but now the transversal, we're going to pay attention to this part, and we are going to ignore this part up here. We don't care. Not our circus, not our monkeys. Not anymore. So for this part, these are also same side interiors. Okay, so we know that 3y plus 44 plus 94, right, all have to add up to 180. Okay, 44 and 94, I put in my calculator earlier, I checked, it's 138. If you subtract 138 from both sides, you get 3y is 42. Divide both sides by 3, you get y is 14. Okay, so both of those pairs were same side interiors and they were supplementary, so that's why we had to add them up to 180. All right, let's look at another one. All right, so here are my parallel lines. Okay, I'm going to start with the one on the right. Here's the transversal I'm going to use. Okay, and I'm going to ignore this part of the problem over here. Don't scratch it out too dark. You'll need it in a minute. So the 2x and the 108 are on alternate sides of my hot pink transversal, and they are in the interior of the parallel lines. So they are alternate interiors. Okay, so they are congruent. So their measures have to be equal. So I know that 2x has to equal 108. If I divide both sides by 2, I get that x is 54. Okay, now I'm going to look at the other part of the problem. Now, this is going to be my transversal. Here are my parallel lines. We are still in the interior, but now we're on same side interiors. So same interior angles. Okay, so those are supplementary. So they have to add up to 180. So 5y plus 120 equals 180. Subtract 120 from both sides and we get 5y equals 60. Divide both sides by 5 and we get y is 12. Okay, last but not least. We're saving this one to the end because you have to get x to find y. So let's find x first and then we'll plug in x and we'll find the y. I'm sleepy, sorry. Okay. So here are my parallel lines. Here is my transversal. So if I look at x and 120, I see that they are on the same side of my transversal and they are interior to my parallel lines. So they are same side interiors. They have to add up to 180. They're supplementary. So x plus 120 equals 180. Subtract 120 from both sides, and we get x equals 60. Okay, now we know x. We can plug it in. So 3 times 60 is 180. Minus 70 is 110. Okay, so this one's 110. Well, this angle and this angle, they're not congruent, but they are a linear pair. And linear pairs are also supplementary. So that 3y plus 40 and the 110 have to all add up to 180. So 3y plus 40 plus the 110 that we use the x to find all have to add up to 180. Well, 40 and 110, that's 150. Subtract 150 from both sides and we get 3y equals 30. Divide both sides by 3 and we get y is 10. Holy cannoli. You can't see that. Sorry. All right, that was a lot. You made it. Congratulations.